Now, what are the chemical technology spaces to which you could apply this compass? And I think of this as a bookcase of problems. Because the bookcase, what you have is you have like problems collected on individual shelves, and as we build the field, we'll put books on. That was the problem, that's how we thought about it, that's what we did to solve it. And we have some very good examples of this. So the first is green synthesis. And most of our major drug houses are involved in this, saving a lot of money, reducing a lot of pollution. And we'll pull a book off it, and we'll open the book and we'll look at it. And I love this one. This is Taxol. Taxol is a potent drug against breast and ovarian cancer. But when it was discovered, we didn't know how to make it. You got it from the bark of the Pacific yew tree, was present in only 4 parts per million in the yew tree bark, and you had to strip the bark, and that killed the trees. This is what the yew tree looks like, Taxus brevifolia, and that's what the bark looks like. It's a very pretty bark, but that's where we got the compound. But it's clearly not sustainable because these trees take 200 years to mature. The published syntheses were 40 steps plus with very low overall yield. That just means real expensive. And so what happened is that Bristol Myers Squibb developed, they took the twigs and the leaves of the plant, and they did plant cell fermentation and got the drug out of the fermentation process and got rid of a lot of toxic chemicals. It was awarded one of these Presidential Green Chemistry Awards that Paul Anastas and John Warner had significant part in developing. But the truth is that each individual one of these technologies or advances do not really shake sustainability in the way. They make a little difference. They're often worth a fortune to the companies, but they are not going to be enough to get a sustainable future by themselves. Integrate over, and so making them better is you just move things a little bit, but they were never really threatening sustainability if we're honest. Collect a whole lot of them, and you've made a big difference. The second level is renewable feedstocks. That feels okay. I'm not going to talk about it. The third is safe energy. We've already talked about that. The fourth is toxic elements. Now, we really do have some work to do here. And if we pull a book off this and look at it, there's no better place to look really than lead. Because lead has tortured this country. Absolutely tortured it. And it never needed to happen. The Europeans were getting rid of lead in the earlier part of the 19th century. This country never really got rid of it effectively till the 1970s. And the net result is, in my estimation, a very large number of dead children and the dumbing down of the entire US population. And if you want me to defend that later, I'll tell you why. It's an amazing story. The book, when it's on the shelf of this, has to do with the history of lead toxicity and ecotoxicity. Incredibly fascinating. The history of lead spin and its consequences, because we had lead in this country had lead because of lead spin. The biochemistry of lead, which shows the toxicity origins, and once you know why the thing is mechanistically toxic and the science has been done, there's no doubt anymore. And we are at that point. We would still learn some more, but we're at the no doubt point. The progress in greening lead, products and process, and challenges for greening lead product process. And there's a phenomenal warning from the Romans. The Romans really were going to be extinguished by lead. They really were. They were probably extinguished by lead. And the reason we know this is that there was a burial ground in Holland. And it's a Roman burial site. And when they looked, they found an extraordinary number of baby skeletons. And they think, well, the Romans didn't sacrifice babies. What are all these babies doing here with a small, comparatively small number of adults? And they looked at the bones and found the bones were absolutely loaded with lead. They looked at the soil around and found there was no lead there. These kids were poisoned and died young, almost certainly because of lead poisoning. Lead poisoning is a terrible thing. This is a biggie. That's because of the mining, and this is because of the poisoning. And our movement here has been positive and substantial, but we have more work to do. The next is persistent molecular compounds. I won't go into that because of a time consideration. And the top is endocrine disruptors. And I'll just simply tell you, in case you don't know, what's the big deal about endocrine disruptors. And we'll pull the book off the shelf and look at this one. So endocrine disruptor is an exogenous agent that interferes with the production, release, transport, binding, action, or elimination of natural hormones from the body, responsible for the maintenance of homeostasis and the regulation of developmental processes. That's the deadly for sustainability. If you get chemicals, which, as you see here, endocrine disruptors can show severe adverse effects in organisms at environmentally relevant concentrations. If you're having chemicals that at 1 part per trillion to up to a few parts per billion can change the way cells develop, you impair the organisms. And this is unquestionably happening throughout the natural world. And humans, we are animals. We are not immune. And there is a great deal of evidence that we have a problem there as well. Now, I'm talking about the problems, but there are solutions, as we will see, or ways to deal with them. Perhaps the signature endocrine disruptor is something we make 10 billion pounds of now per year. It's in so extraordinary range of our products, bisphenol A, and we have to deal with it. The book here will look like the following. It's chemistry and commercial uses, the history of its adverse health effects, the early evidence, the obesity, neurological, thyroid cancer, reproductive and sexual behavior, implications of it, the phenomenon of conflicting studies, most interesting, and I've actually lived through that with my friends and seen it in real time. It's extraordinary. The importance of controls and conditions, what the experimental statistics mean, a critical thing to analyze the deep science, the history of industry and environmental health scientific disputes, global government and industry responses, mechanisms of action in pharmacokinetics, the search for alternatives, and the state of the assays for alternatives, which is a really critical thing I'll talk about in a minute. Bisphenol A shows severe adverse effects in animals at environmentally relevant concentrations. We have to deal with it. It's a biggie. And we've made a little improvement, but only a little improvement. We have a long way to go with bisphenol A. Now, the interesting thing is that you may be tuned into the fact that I'm talking about quite a range of molecules. And you think, well, now how are we going to go get rid of that thing and that thing and that thing and that thing and that thing, etc. Ultimately, we may get to the point, the ideal point that John will talk about, where all chemicals are safe, as an aspirational goal, as he puts it. But in the meantime, in getting there, it would make a huge difference if once the thing had been used, we could remove it from the environment easily. Now, with bisphenol A, that may be a little hard to see why you do that, but when you think about the implication that most of our drugs fall into these categories, and we really need those drugs, seriously need those drugs. And so drugs these days are designed to be highly bioactive. The more bioactive, the better. Highly bioaccumulative, because if they stay in you and stay in living organisms, they work better. And resistant to degradation, because otherwise the liver fries them with exactly the same kind of chemistry that my catalysts have mimicked. And so the problem is the use, the value, is tied to the toxic properties. And it's really hard to imagine us throwing away ethinyl estradiol, the reproductive pill. But the reproductive pill, ethinyl estradiol, because it's such a potent estrogen, has an unbelievable effect on the environment, in rivers, etc. So a big advance is to be able to remove it from water easily.